Artificial intelligence is getting, well, superhuman. It's solving these massive problems, things like protein folding, turbulence control, you name it. But here's the paradox, and it's a big one. These AIs are unbelievably powerful, but how they think? It's often a total mystery, just a black box. So let's dive in and see how we're starting to peek inside that box. And this quote right here, it really gets to the absolute heart of a field called explainable AI, or XAI for short. The whole idea isn't just about using AI as another tool in the toolbox. No, it's about asking a much bigger question. Can we turn it into a collaborator, a partner that can actually teach us new things about the universe? I mean, think about that. Can we learn from the very things we've created?
And yeah, that is the core challenge right there. This is the black box problem. Imagine an AI designs a life-saving drug or predicts a hurricane's path. It might be spot on, but if we have no idea why it's right, can we really trust it? How can we make it better? And what happens when it's wrong? We can't fix what we don't understand. This opacity, this lack of clarity, is exactly what XAI is here to solve.
So, you see, XAI isn't just about us being curious and wanting to know what's going on inside the machine. It's way more practical. It actually gives us a roadmap, a framework for a totally new kind of partnership between humans and AI. And this partnership is built on three really important pillars: discovery, optimization, and certification. Let's break down each one.
All right, first up, discovery. This is maybe the most exciting one. This is where we're not just asking the AI to tell us what's going to happen next. We're asking it to help us understand the why, the fundamental rules of the game, the actual laws of nature that are buried deep inside all that data.
Now, the guiding light here is a principle scientists have loved forever. It's called parsimony. You've probably heard of it as Occam's razor. Basically, the simplest explanation is usually the best one, right? So an AI that spits out some ridiculously complicated solution, that's not really helping us. The real magic is when an AI can take all that messy data and boil it down to something simple, elegant, and, well, understandable.
And this isn't a new idea. History is full of this stuff. Take Ptolemy's model of the universe. It was this crazy, complicated system of circles moving on other circles to explain how planets moved. And for its time, it was surprisingly accurate. But then along came Kepler. His model, with simple elliptical orbits, was actually a bit less accurate at first. But it revealed a deeper, more fundamental truth. And that simple truth is what allowed Newton to figure out gravity. The lesson: sometimes a deeper understanding is way more valuable than a tiny bit more accuracy.
Okay, so that's the goal. But how in the world do you get an AI to do what Kepler did? How can it possibly look at a mountain of overwhelmingly complex data and pull out that one beautiful, simple law that's hiding inside?
Well, one really clever way is with something called an autoencoder. Let's walk through it. So, step one. Imagine you feed an AI a ton of high-dimensional data. Let's say it's a super detailed video of a pendulum swinging back and forth. I mean, we're talking about an enormous amount of information. Every single pixel in every single frame.
Okay, step two. This is the crucial part. The AI is then forced to compress all of that information, all of it, through a very narrow bottleneck. It's like trying to push a river through a tiny pipe. It simply has to decide what is the most essential, critical information needed to describe that pendulum, and it has to throw everything else away. It can't remember every pixel. It's forced to find the underlying principles.
And then, step three, the discovery. What comes out the other side is just amazing. The AI figures out that to perfectly recreate that entire complex video, it only needs to track two things: the pendulum's angle and its speed. That's it. It has, all on its own, discovered the fundamental physics of the system. It's turned a messy video into a simple, parsimonious model. Just incredible. So once you can discover the fundamental rules of something, what's the next logical step? Well, you try to make it better. And that leads us right into our second pillar, optimization. Because, in engineering, understanding the world is great, but we really want to change it, to improve it. And this is where XAI is helping us build smarter, more efficient.
But here, we hit a different kind of problem. It's kind of like a translation issue. An AI might come up with a genius solution, say, a way to reduce drag on a jet wing. But its solution exists in what's called a latent space. Just think of it as a super compressed, abstract language that makes total sense to a computer, but is complete gibberish to a human engineer. And obviously, we can't build something if we don't understand the blueprint.
This is where XAI steps in to be our translator.
There's a whole toolbox of techniques for this. You've got things like saliency maps, which are basically heat maps that show you what parts of our problem the AI is focusing on, what it thinks is important. These tools are designed to bridge that gap between the machine's abstract idea and our physical world. They show us exactly which parts of the design are having the biggest impact.
And this really gets to the power of understanding why. See, instead of just telling an AI, hey, reduce the drag, which is just treating the symptom, we can use XAI to ask it, what specific physical mechanism is causing the drag? When you optimize for the root cause, you get much, much better solutions. It's really the difference between just taking a painkiller for a headache versus figuring out what's causing the headache in the first place.
And that brings us to our third and final pillar, certification. Honestly, this might be the most important one of all if we ever want to bring AI into the really high-stakes parts of our lives. You know, the areas where failure just isn't an option. At the end of the day, this is all about trust.
I mean, just think about it. Self-driving cars, AI that diagnoses diseases, the systems that fly our planes. In fields like these, the answer, it just works, trust me, is, well, it's never going to fly. It's completely unacceptable. We have to know exactly why the AI made a certain decision. And if, God forbid, something goes wrong, we need a paper trail and audit trail to figure out what happened.
And this really points to a huge shift in how we think about this. The old way of doing things, you could call it trust by performance. Basically, if an AI did well on a test, we'd say, great, ship it. But the problem is, that leaves you totally blind when it eventually fails in the real world. The new model, thanks to XAI, is trust by understanding. Here, we don't just certify an AI because it gets the right answer. We certify it because we can see that its reasoning is sound, that its process is robust, and that it makes sense.
So you see, explainability is not just some nerdy academic exercise. It's the key. It's the mechanism that lets us do things like regulate AI, formally certify it for those safety-critical jobs, and, this is a big one, figure out who's responsible when something goes wrong. It's about treating AI with the same seriousness and rigor we'd use for a bridge or an airplane engine.
All right, let's pull it all together now. We've got our three pillars: discovery, optimization, and certification. When you put them all together, what you start to see is, well, it's a glimpse of a pretty radical new future for how we do science and engineering.
Okay, I know this diagram looks a little complicated, but hang with me, because the core idea here is absolutely revolutionary. What it's showing is a future where these huge AI models, guided by other AIs, can go out and explore new scientific frontiers pretty much on their own. And the whole time, XAI is right there in the middle, acting as that crucial bridge, constantly translating what the machines are finding back into something we humans can understand. It creates this amazing, continuous loop of discovery, checking our work and gaining new insights.
Now look, we're not quite there yet. Let's be real. There are some big challenges still ahead. For one, an explanation can be mathematically perfect but make zero sense to a human expert. That's a problem. We also have to be super careful that the AI has learned a real cause and effect relationship and not just some random correlation in the data. And, of course, the explanations themselves have to be stable and reliable every time.
But the ultimate goal here, it's really profound, and this quote just nails it. The point of XAI isn't just to justify a single prediction, to say this answer is right because of X. No, the real goal is to transfer a whole new level of understanding, a new way of thinking from the machine back to us, the humans. It's about leveling up our own scientific intuition.
You know, the history of science is really a history of new tools. The telescope, the microscope, each one opened up entire new worlds for us to explore. So what's the big takeaway here? I'll leave you with this question. Is explainable AI the tool that finally lets us change our relationship with our own creations? To move beyond just giving them instructions and to start, for the first time, a true scientific collaboration?